Yes. Yes.
Thanks.
Hey everyone. How are you all doing? Good? Okay. Before I start the lecture, do you guys have any questions? About anything? Okay. I had some of you contacting me about the exam and then your concerns about your grades. As you know, we have tutoring available and I assigned 5 extra credits for each tutoring sessions that you go. So if you didn't, receive the grades that you expected, you can easily increase your grades by going to tutoring. And we have like the workshops on Thursday, 6 to 8, and Sean is going to switch them back to Mondays because of his schedule. And if you cannot go to his tutoring sessions or workshops, you can just go to any tutoring sessions. And if none of those work for you, just email me and I just schedule tutoring sessions with you myself. So you can receive the extra credit. And even, if you go to two tutoring sessions a week, you receive 10 points. And I think that's fair, and you can easily increase your grades. Any questions or concerns? Good. And the other thing, I had some of you message me about your homework assignments. And sometimes, you don't receive the grade that you expect to receive, although you know the materials well. So if that happens and keeps happening, maybe you think that you learned the concept, but you didn't, or still you didn't pay attention to a specific question. So I encourage you, if that keeps happening to you, before answering the questions, kind of go back to the slides and check your answer to make sure that what you're choosing is indeed the correct answer. Does that make sense? Okay, and also, again, some of you asked me to go through the homework problems, and I was doing that 2 sessions, and it took almost our entire class, and I need to progress with the lectures. So what I'm going to do, I'm going to record videos explaining the problems for each homework individually. So I'm going to add another module to your modules. And that would be homework and quiz solutions videos. So I already posted the solutions, but I realized that is only the final answer. So I explained the questions, and if you have any difficulties, you can just go to that specific assignment, or if there is a specific question, you can just fast forward to go to that specific question. Does that make sense? Any questions, concerns, anything before we progress with the lecture? Okay. If not, I'm going to start with the lecture, and that is 16th lecture. And as I mentioned, everything that I write here would be from our textbook, and unless I have another link or tell you that I got this from the other website, okay? And some other thing before I start the lecture, I want to emphasize that you should read the book. Just looking at the slides and coming to the class, it won't do. You should read the book, okay? And as I mentioned several times, if you have difficulty getting the book, just contact me and I can help you to figure out what the issue is, okay? I know that for some students, they just used to coming to the class, listening to the lecture, go home, do the homework, and that's it. That is not the case for our course. For each lecture, for each 50 minutes, you should at least study 1 hour at home, okay? So make sure also to do that. Sometimes the problem is that you know the materials, but you didn't practice enough. That's why when you see a question in the exam, you get confused. Hydrogen bonding, what was it? Is HBr, being considered having hydrogen bonding between their molecules, so you get confused, because you didn't practice enough. So make sure to practice, and if you have any issues at any point, contact me. And the other thing about homework assignments, quizzes, and everything, I just cannot emphasize enough that if you have difficulty or you're sick, or you have like family emergency, if anything comes up, just communicate with me before the deadline, not like 1 hour before or after the deadlines, okay? And don't, be afraid to just reach out to me anytime, okay? Okay, enough with the talking about like these things. So I'm going to start, I get some time. Okay. And just let me know if the link don't work or give you a hard time. And something that one of my students in the other class told me is that when you put like lower letter, or capital letter, if you mix them up, the link won't work. So make sure you have like, E, small letter V, capitalized, T, small f, capitalized, and so on and so forth. And your homework 6 is due tonight, and something that I noticed with the class is that most of you don't go back and read what you had wrong in the last homework assignment. So 5 of the questions is exactly from your quiz 2. So, I mean, it's no point, if you don't learn the question. Yes?
Is there a way to figure out which questions you exactly missed? Because I haven't seen that or been able to, if there is.
Yes, you can just like email me if you don't remember what you answered or like which question, and I send you your solution, the thing that you answered, and you can just like copy it, or like rather, a print page option, in like the Canvas, and I can send you exactly your quiz or like homework. I just hold on attendance because I want to progress with the lecture. And what I'm going to do, I'm going to try something new. And usually I have like prepared slides, and I also have them. I thought maybe I try to just like writing as I teach, and I see how that goes. Okay, and then you guys can tell me which one you liked more, whether having like the prepared slides or just like me writing things as I'm talking. Does that make sense? And I will post all the slides, so don't feel obligated to just write everything quickly. So now we talked about previously about oxidation, reduction reactions. If I can make the pen work, oxidation, reduction reactions. And we were specifically talking about alkanes. Can anyone tell me what was oxidation reduction reactions in general?
Loss of electrons.
Exactly. So we have transfer of electrons in oxidation reduction reactions. And as you remember, combustion reactions were a category of oxidation reduction reactions because it involves transfer of electrons, right? And that was one of the reaction types that alkanes would participate in, right? So do you remember alkanes? What type of intermolecular forces alkanes have? Do they have hydrogen bonding? Do they have dipole-dipole? Why? They're not polar. So what are alkanes? Can anyone tell me the general formula? CNH 2n plus 2, right? And do you remember when we were talking about electronegativity of carbon and hydrogen, we said those are close enough, right? So these bonds would be polar or non-polar? Non-polar, right? So what type of intermolecular forces are between non-polar molecules? London dispersion, right? So if I ask you in the quiz, homework problems or like exam, that alkanes have hydrogen bonding between them, that sentence would be false, right? Because we have like London dispersion in alkanes. And in general, we said they are inert because they're non-polar, right? But there are two specific type of reactions that they participate in, right? One of them is oxidation reduction reactions, and specifically combustion reactions, right? We burn methane, propane all the time. So this type of reaction they participate in. And the other type is halogenation, and that is 212B, the second type of reactions that they participate. So if your book categorized them like 212 was combustion, oxidation, reduction reaction. 212B is halogenation, or halogenation of alkanes. And in general, what it means is that we have like alkanes and we show them as like RH, that they have like one hydrogen, and then the rest of the alkane we show that with R, right? And do you remember, for instance, when we had like the radicals, we showed that with R's, right? So for instance, here we can have like CH3 attached to a hydrogen, and that is, you know, or like that is CH4, right? So in general, your alkane has a hydrogen, and this is the rest of the alkane. Does that make sense? To show these halogenation reactions, we want to emphasize that we have a halogen being substituted with one of the hydrogens of alkane. That's why we write them this way. Does that make sense? So here you have your alkane, and that reacts with chlorine molecule. And remember that halogens, we have them as diatomic molecules, right? F2, Cl2, Br2, I2, right? Do you remember? I'm just thinking that I'm talking to myself. So, does that make sense? Any questions? So what other molecules are diatomic? Can anyone give me another example?
Nitrogen.
Nitrogen, yes. Oxygen, right? Hydrogen, right? So we don't have, I mean, we may have, but in general, at room temperature, at normal conditions that we're dealing with, we don't have only one hydrogen atom or like one oxygen atom. In the air that we breathe, we have O2 molecules or N2 molecules, right? And in general, remember that if we have like alkanes and halogens and we store them next to each other, nothing happens. But if we give them light or considerable amount of energy, in general, if we give them light or heat, they will react with each other. It's kind of like the combustion reaction that we talked about. If I have methane here with oxygen, nothing happens. But if we give them like some energy, the spark that we talked about, we'll be having combustion reaction. And we definitely don't want to do that in the classroom, just like in this setting, right? Okay, so any questions so far? So what happens here is that, and I try to highlight as best as I can, here we have like the hydrogen, and here we have like these chlorine atoms, right? So what happens, one of these chlorine substitutes this hydrogen. So what happens is that here, instead of having RH, we will be having, I guess I just write with black, easier to read, RCl plus, and what happens if I switch these to what?
HCl.
Exactly. And can anyone tell me from like previous chemistry courses that you learned, what type of reactions we call this? So we have like synthesis, you know, different types of reactions, right? We have combination, right? Different types of reactions. What is this one?
Single substitution.
Exactly, we have like substitution reaction. So here, substitution reaction. Because basically you substituted one of the Cls with this hydrogen. Okay? Any questions so far? And specifically for this reaction, we call this chlorination reaction. Because you substituted chlorine with hydrogen in the alkane. And we can write really similar thing for bromine. If I have like RH plus Br, so write that smaller, Br, and then if we give it light or heat. Sometimes I just like mix the words in my head, it comes out wrong in my mouth, from my mouth. Anyway, so can anyone tell me, in the same way that we wrote this substitution reaction, what should I write here? Exactly. So basically what we did is that we substituted these two, kind of, I guess one will do. These two, we switched them, right? So we have like RBr and HBr. And we call this reaction, it is again a substitution reaction, and we call this bromination. And we call that when the source of halogen is bromine molecule. Any questions so far? Now I go here. So imagine if I have CH3Cl, okay? And here, if I write the whole reactions, again, this was like the general form, but I can give you any of these, for instance, for RCl, RH, right? If I substitute this R with CH3, it would be CH3H plus Cl. Then here if we give light or heat, we have CH3Cl plus HCl, right? So this is exactly the same thing that I wrote, here, but this is kind of like a more specific example, right? That I substituted R with CH3. And here, so remember, or pay attention that we have like CH3Cl. So if I have more of chlorine molecules, what can happen is that, again, this CH3Cl can react with this ClCl, right? So I can write similar thing here, that CH3Cl plus ClCl, it gives me, and again with light or heat. So what do you think that would give me? What's that?
Would it not be the same thing?
So I want to substitute this hydrogen. Remember, here I have like the hydrogen, and then here I have the chlorine, and I want to, substitute them together. So how should I write this one? So here for CH3Cl, if I substitute one of the hydrogen with Cl, right, what would be the result? CH2, yeah? Yes. So it would be CH2Cl2, right? What's that?
Is there a plus Cl? Do we account for all of them? Right?
So, one of these hydrogen goes away and then substitutes with like this Cl, and then you're right, this hydrogen goes here and then it becomes plus HCl. Can everyone see that? So in the halogenation reactions, you have like one of your hydrogen in your alkane being substituted with the halogen that you have. Does that make sense? But this is this type of reaction. You may have like other types of reaction, but for halogenation, this is what is happening. That one of the hydrogen here goes, and then we talk about mechanism of this reaction in a moment. But as of right now, one of these Cl's goes here, so you have Cl2. This hydrogen comes here, HCl, and this one becomes CH2, Cl2. Right? And in these reactions, as you see, we have like lots of writing to do, and your book and chemists in general, they like brevity and kind of like having like more concise way of writing things. So in these types of reactions, what they do, they just write CH3Cl, and then in the arrow, they write Cl2, meaning that CH3Cl is reacting with Cl2. So this is kind of like analogous, the same thing that we wrote above. So instead of writing plus Cl2, they write an arrow, and in the arrow they write Cl2, and then they write CH2Cl2. And sometimes they don't write HCl because they know in their head that, okay, HCl is also being generated. But these things, again, this comes with practice. You should kind of write the whole version, the complete equation, and after you do like several of those, you see that HCl is being repeated. So that's in your head. Or instead of like writing Cl2 here all the time, you just write it in the arrow to be faster. Does that make sense? And again here, you can write in the arrow Cl2 again, meaning that CH2Cl2 reacts with Cl2, and one of these hydrogens being substituted with this, one of the chlorine atoms in chlorine molecule. And can anyone tell me what would be the result?
CHCl.
Right? So you, in your head, deduct one of the hydrogens and add a chlorine atom. Does that make sense to everyone? So what if I do add another Cl2? What would be this result? Exactly. So this is how we write, halogenation reactions. So we substitute a hydrogen in alkane with the halogen that we have. And then they always generate HCl. Any questions? So let's do another example. And again, I cannot emphasize enough that after we're done with the lecture, I encourage you, I ask you, or I tell you, to, when you go home, you kind of like open the book, and, or like in your browser, the online version, kind of like read the book, and then ask me if you have any questions, okay? But let's do another example. So CH3, CH2, CH3. First of all, what is the name of this compound? It's C3H8. Propane, right? What happens if I mix that or like make it react with Cl2 and I give it light or heat? What would be the result? Can anyone tell me?
CH3, CH2, CH2, Cl.
Exactly. One possible option can be this, right? So basically, what your friend did is that, eliminated one of the hydrogens here, so wrote CH2 and added a chlorine atom. Right? But what if I eliminate one of the hydrogens here? So if I write CH3, CH, CH3, and then I substitute this hydrogen here with Cl. Do you remember the different isomers that we had, like for propane or like for butane? So this one is isopropyl But for butane, we had like more of them. This one has 3 carbons, but for butane, exactly, we had like sec, tert, isobutyl, right? So in this case, this one would be isopropyl chloride. And I have the luxury of having the book in front of me, so I'm sure of the answer, but. Or, so basically it can be like this plus HCl. So the point is that if you have like different, if you have like more number of carbons, if you have like propane, butane, and then if the chlorination or halogenation reactions occur, you may have like different products, different isomers, depending on which hydrogen is being substituted with the, which of these hydrogen being substituted with the chlorine atom. Any questions? Good. Okay, so now let's do another example. So what about this one? If I just give you this, what is the name of this compound? Exactly. Cyclopentane. Right? We have like 5 carbons in a ring, right? So we have always cyclo and then pentane. So now if I add bromine molecule to it and then I give it light, right? So now what happens is that, again, you'll be having your ring, and as a fact that one of these, so if I write this completely, how many hydrogens I have here? 2, and then all of these, right? So we have like 2 bonds, and then carbon's valence is 4. So, and in general, in these kind of structures, we have like more branches and all that. But in general, just as of what you see here, remember that valence of carbon is 4, so it can have like 4 bonds. Anyway, so if I consider like, this specific carbon here, and I want to substitute one of the BRs here with one of the hydrogens here, so here already had like, if I eliminate that, it would be CH2, something like this, right? So one of these, for instance, this one I substitute with BR, right? So I will be having this structure plus HBr, right? So it's similar to what we did before, but it's just like you have a ring and then you substitute one of the hydrogens, here, and then if you even substitute the other one, the structure would be just the same. It's just kind of like the other carbon, right? So the name and anything, it won't change. Remember when you had like one branch, the name was like the same, and it didn't matter which of them had the branch. Does that make sense what I'm saying? In the sense of naming. And we call this one bromo cyclo, if I can spell it, cyclopentane. Any questions? Okay. Now we want to learn about the reaction mechanism. And in general, before I start writing this, all the reactions that you see or we write on the board or we have written so far is the final reaction, right? And in general, in nature, it's not like, the reactions have like different steps. So each reaction has several sub-reactions. So if we have like this, halogenation, this is the final results that we see, and it consists of different steps, and when we add all the steps together, we see the final result. Does that make sense? So molecules, it first the bond between the reactants break, and then they, start reacting with one another, and there are like different steps. So it's not like that, magically one of these Br atoms, substitutes this one, and then you magically see these things. There are like several other things happening, and this is what we call reaction mechanism, and I'm going to talk about it, and this is like section 213 in your book, and we call that the free radical chain mechanism of halogenation. And as I mentioned, in general, all the final reactions that you see, there are the result of several different subreactions that when they occur, at the end, we see the final reactions that we are seeing. So in general, I guess I write their definition here too. A reaction mechanism is a step by step description of the bond breaking and bond making processes that occur when reagents or reactants react to form products. So in general, when we talk about reaction mechanism, it means that which bonds have been broken, and then which bonds being formed, and it gives us kind of like the detailed description of what actually has happened, right? And remember that the final reaction, the reaction that in general we have been writing, it's like just the final product. It's kind of like adding all these things together. Okay? Any question about reaction mechanism? Okay, so in the case of, and as I mentioned, I also have like the slides for these, but I thought that maybe it's like, I can explain better if I can write this as I go. So first of all, if I want to write Lewis structure of chlorine, how can I write that? Can anyone tell me what is the first step? Exactly, chlorine is in group 7A. It has like 7 valence electrons, and we write that 1, 2, 3, 4, 5, 6, 7. So another chlorine, again, I write the same thing, 1, 2, 3, 4, 5, 6, 7. And remember that these 2 electrons are the bonding electrons, right? And then we would write a dash between them, or in this case, your book wrote them vertically. Doesn't matter, as long as you know that these 2 electrons are bonding electrons, and then you have like Cl-Cl molecule because of that. And again, remember, I may ask you further in the course as well that how many non-bonding electrons Cl-Cl has. So if you forget, write the non-bonding electrons as well, because sometimes if you don't write them, you forget to count them. So kind of like review of like counting, non-bonding and bonding electrons. So here, the first step, so we studied the overall reaction here, right? And this is what I'm talking about, that we say this is the reaction, but this is not, we magically don't CHCl and RCl. We have like different steps. The first step is initiation. And initiation means that you have like this chlorine molecule, and these, you give it light or heat, and you get chlorine atoms. So basically, you have like chlorine molecule, and we call this, go a little to the initiation. So initiation is basically getting chlorine atoms from chlorine molecule. So you have like Cl, basically the same thing that I wrote before, right? Just one chlorine atom. And you can write these dots the other side too, doesn't matter. You just get like 2 chlorine atoms. The next step is, propagation. Propagation. And then it has 2 steps. One of the steps is that, again, you have your alkane, right? And then remember, we wrote that as RH because we have like an alkyl or like radical rather plus attached to a hydrogen, right? And that react with this, chlorine atom here, and we get, so exactly, we get like HCl plus here we get just like an R, right? And do you remember what was the definition of like radical? Exactly. So you had like here an odd number of electrons. Usually, we're used to having like, 2, our non-bonding electrons is usually even. It's kind of like not so much convenient for us, or at least, I don't know. I just used to having like even number of electrons. So in radicals, we have like, odd number of electrons. Here is like 1, right? And is that clear why that happens? Any questions? Okay. And the other step is that this R radical that we have here that reacts with like, chlorine molecule, and we have, RCl plus another Cl. And then here we have like alkyl chloride, and here we have like the chlorine atom. So this is like the second step, and we call that propagation. Okay? And again, the general overall reaction of halogenation we wrote before, these are like in molecular level what actually happens between the bonds between chlorine molecules themselves and also alkanes, and kind of like between alkanes and halogens. Okay, kind of try to have all of this while I write the last one. So the last step is termination. And in the termination, we have like, Cl. You see that we have like, Cl here. And again, remember, the Lewis structure of Cl. We have like 7 valence electrons. So we get like Cl, and then we have like these R radicals here, plus R, we get like R, and then we get like R plus Cl. The book has like 1. Yeah, I think this one should be also 2 of these. Okay, and now here, but let me go kind of like to the slides. Yeah, I mean, so we have like different steps, like initiation, as I mentioned, that we have like the chlorine molecule and then it turns into chlorine atoms, okay? Okay. And then the next step, we have like, our alkane plus one of the chlorine atoms that was generated before, and then it forms alkyl radical and HCl. And in the next step, this, radical plus, again, ClCl molecule gives like alkyl chloride plus Cl, kind of like this, substitute this, right? So it becomes RCl plus Cl itself. We have then in the last step, in the termination, we have like these Cl's bond together, and then we have Cl2, and also the two radicals bond together, we have like RR, and also we have like R and Cl that form RCl. And then I kind of like bothered with this one dot here. Does anyone have an idea of this one? I think that might be a typo, but I'll look into it and then let you guys know if that's not the case. But I feel like this one should be also two dots. But this is kind of like the general reaction mechanism. And again, this is kind of like something that, scientists went to the laboratory and then they experimented these things, and then they found out about these reaction mechanism and how these things happen actually in the laboratory setting. Yes?
So do chemical reactions typically only occur because the propagation stage is super unstable?
So yes, I mean, for each reaction is different. So specifically for halogenation reactions, that's the case. And usually when you have and we talk about these things in more detail as I progress with the lecture, but I might have also, I think I also talked about this briefly, like halogenation of alkanes, since the, previous steps, that we talked about, or propagation specifically, is not that stable. We want to have the last step, so we have so alkyls and radicals, they're not stable because they have one odd number of electrons and they're really reactive, so they want to reach to a lower state energy. So that's why we have this, but each reaction mechanism is different, and this is specifically for halogenation reactions. Great question. Any other questions? Good. Okay, so now let me kind of go to chapter 3. And again, I asked you guys to read the chapter and then this part that we talked. I guess the only thing that I didn't talk about in the class, and I mentioned that previously, it was different types of, hybridization, like sp3, all that, and then also different, when we had conformation or isomers. Your book has lots of examples of rotate this molecule 60 degrees, which other structure you get. So I don't expect you to know those things. But except that, we almost covered the whole chapter. So read the chapter and ask me if you have any questions, okay? And I really want to start chapter 3, so at least I say I started that. So we want to talk about alkenes and alkynes. And this is kind of interesting. So we have alkane, alkene, and alkyne. And again, your book, knew who he is or they are talking to. So it was this is rhymes with wine. So kind of if you get confused, I was wondering how you pronounce that, because in Farsi we call these, alkan, alkane, alkene. So, or like we say like eton, eten, etene. So it's kind of like, different than English, I guess. And this is like, alkane, alkene, alkyne. So just remember that these are like different. And depending on what we have here, the general formula and the structure of these changes. So we talked about alkanes a lot. Can anyone tell me what is their general formula? Exactly. So for alkenes, we have CnH2n. Okay? And these are, again, things that you should just like remember, and there is no other way, I guess. There is not like that much of scientific explanation. So I try for everything that I teach, give you a good, valid explanation to remember, why boiling points of hydrogen bonding is higher. So you don't have to just like memorize it. So, but for these things, it's just like things that scientists agreed on, that this is what we call this, compound. We call that, alkane, and it has the general formula of CnH2n plus 2. Okay, so if it's CnH2n, we call that alkene, and if it's like CnH2n minus 2, we call that alkyne. And every name that we wrote before, like methane, ethane, propane, butane, pentane, and so forth, now we can write, the alkene or alkyne version, right? So what would that be for one carbon here? The name. So if I write C, if n equals 1, yes? So CH2, right? I'm writing for this guy, right? So C1, H2 minus 2 multiply by 1 would be CH2. And what would we call this? Exactly, methane, right? And then you write C2H4, ethene, right? And then propane. And then here the same thing. If n equals 1, what would be the formula? Yeah, so we start with n equals 2, right? So if n equals 2, it would be like C2H2, right? And we call that ethine. Okay? And then for the next session, I write you all the names in a table so you can just refer to them, and then knowing the name of the, depending on how many carbons we have, what structure you will be having. So let me go to the attendance. Previously, that when we have like this, reaction mechanisms, we have like, we need like an activation energy to reach to the state that, all the atoms are kind of like separate from their, so basically the bonding between molecules or your reactants, they break and they want to form bonds, with the other reactants to find product, to form products. And depending on the interactions between reactants and, products, and, we can like see the reaction, or bond energies between the reactants. What are those numbers, and what are the bond energies between the products? And then depending on which one is more stable, we may or may not have the products. That's why we have like certain types of reactions occurring in nature, but the other types we don't. This goes back to these like reaction mechanisms, and also the bond length and also bond strength between the potential products or reactants and all that. So in general, yes, for